All right, so in our last class, we basically looked at cross origin resource sharing. We also looked at middlewares. And then we basically realized or we saw that middlewares are basically functions that process before and after every request. And they can come in handy for so many things. Probably things that you want to validate a request before it's being passed to a route function, and you want to also validate the response before it's being sent back to the client. So they can come in into these things. Or you have to configure a certain parameter before a request or a certain parameter after a specific request. So this concept is very important and can come in and never can tell when, but it's good that we have a knowledge of how that works. So we'll just continue from there, and this is more like should I say the core part of being what of writing APIs. Okay, the ability to do what to share resources, the ability to share resources, and these resources are basically what resources that we fetch from our databases. And in today's class, we are basically going to see how you can do how you can connect to what to a database and do what carry out some fetch some resources and do what send back to the client. And I'm gonna look at that in today's class. So probably most of us are basically thinking that we are likely going to be writing some SQL queries. No, we are not going to be writing SQL queries. Okay, so thank God to the concept of ORM. Okay, we're gonna make use of the ORM concept. Okay, and and the way this concept works is that you don't necessarily need to do what to write SQL queries, okay, to 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 fetch information from database. Okay, so the way ORM works is that you we represent a table in a database using classes. All right, so it basically map your classes towards to a table in a database, and then the attributes of those classes can be considered as a column in that specific table, and each instance of that class can then be considered as what as a record in that particular table. Now, that actually sounds strange, but then when once we get into writing the actual code, we get to see how this thing works. Okay, so as usual, we do what we have to um, put up our project folder and every other thing we need to want to write our code. And it's a recurring process, so we are already familiar with this process. So quickly, I will go to my project folder, which in this case is my desktop intermediate. All right, and this is where we have our files. So that is where we have our files. So I will simply just copy that URL. So this man is not doing. All right. So before next up. All right. So all right. So now after we've done the, we can start writing our code. So this process is kind of a recurring process, and we're already familiar with this process of putting up our project folder and the rest of them. So I'll just change directory into there and then activate our environment script, and then we activate. And then we see into our main folder, and then we open it up in VS Code. All right, so this is basically where we left off in our previous class. So this is basically where we left off in our previous class. So basically for this particular class, I want to create a new file. Okay, so we're gonna have a new file that we're gonna start the whole concept of relational database separately. Okay, so we've already had a lot of code going in here, right? So let's start this one in a new file. So I'll call it one main two. Okay, a second file. Okay, and we basically just break in the necessary library that we do what that we need. So quickly, I'll just copy from the other file and we edit and it fits our needs. So we need our fast API, uh, and then we need to instantiate this map. We just create a very simple route. A very simple route. So I'll just get this one and copy it and just paste it. And this man here will just be a route directory, a route route. Okay, so nothing much about that route. And just a hello world. All right. So that is that, and that will help us to start with our project. And so I'll just launch. Go ahead and run our terminal and make sure that is working as expected. Ship this mountain and view this one. Bring up the terminal. Ship this mountain. All right, then switch this up to command prompt. Okay, so basically now we can use VUVCon and then our file name, in this case main2, followed by the instance of fast API, followed by what the reload command. So that should be UVCon. And we are missing our C. So this should be UVCon. All right, so let's put this up and be sure that this is running as expected. So go to our browser, paste this up there, and yeah, that is we're working as expected. All right, so key thing that we have to put in mind is first of all, I'll put in some comments here. So first of all, fast API, all right, fast API doesn't require require you to use relational database. All right. So we have different kinds of database, which I believe we already know. So we have relational database being one type of it. Then we have graph and the rest of them. So there we have different types of database. A relational database is the most common one, right? And for this class, we're gonna make use of one of it. Okay, and then under relational database, we have a different set of them. So we have MySQL. We have MySQL. So MySQL is a type of relational database. When we call this people relational database, it basically means that the means of or the way in which they save information is in a tabular form. So it means that information is being saved in rows and columns. So this databases right support that configuration where information can be saved in tabular format. So SQL actually supports it. All right. We also have PostgreSQL. Post post right. Postgres. Keep missing that. All right, and then we have SQLite as well. So SQLite is more like a file database, right? So it's not actually convenient for production. But for this particular class, we'll make use of what of SQLite, right? Then once we get to deployment, we can actually see how we can migrate from SQLite to a good database such as MySQL or what of PostgreSQL, right? But for this class, we're gonna use what MySQLite. SQLite is what is an example of a relational database, right? So having that in mind, what do we need to put in order to have this worked out? All right. So what do we have to put in order? So another thing again is that we are still going to make use of the concept of ORM, All right. And ORM actually means object relational mapping. So it stands for object relational relational mapping. All right. So the thing here is that now it's ORM is a concept though, or you could say it's a programming concept. Right? It's a programming concept. Right? Concept. So basically, how does this concept work? Right. So I actually explained that before now, but I'll go ahead and explain that again. Now, the way this concept works is this. All right. The way this concept works is that it allows you to do what? To interact with your database. All right. Without you doing what? Explicitly writing SQL queries. So it allows you to interact with your database, using high high level programming. Let me just break this in. Using high level programming language. Using high level programming language. Using high level programming language instead of raw SQL queries. So that's basically how the concept of ORM. So it enables you to do what? To directly interact with your database using a high level programming language, which in this case Python. Python is a high level programming language, not a query language. So, but they within your Python, you can do what? You can interact with your database without doing what? Without necessarily writing a raw SQL queries. And there are libraries that helps you do what? To carry out this concept. There are libraries that help you carry out this concept. And the most familiar one, or the one that if you're coming from another Python web framework, you must have heard of Django ORM. Has anyone of us heard of Django ORM? Or have anyone of us heard of Django?
I've heard of
Anyone?
Django.
All right. So there is Django ORM as well. Okay. So it's actually built into Django web framework, and it allows you to do what? To carry out the concept of ORM. So you basically you do not need to explicitly write SQL queries. So Django is one of those libraries, but we can't use that library. That's because that library works only for Django web framework. So it must be within Django web framework. So we have another one called SQL Alchemy. So I believe that we must have heard of SQL Alchemy. So this one is framework independent. So it exists on its own. You can basically use it within your Python file, all right, and it will help you do what? Carry out that concept of ORM. Okay, so we need that library since we do not intend to write raw SQL queries. We need this library. So, but this library is not a fast API. It's not that we want to bring it in and do what and use it within fast API. Fast API has no affiliation with SQL Alchemy. It is a separate open source Python library. Okay, so we are gonna bring that man in, and we're gonna do what? Start interacting with our database using Python programming language. All right, so we have to put few things in place, and then we can start interacting with this thing. So at this point, at this level of that we've actually arrived, okay, it won't be nice, all right, to put all our entire code in one source file. All right. So in this case, we need to split our code in separate files because we intend to manage database connection in one file, though you can do everything, though you can do all these things in one specific file, there's no problem. But then at this point, I want us to do what, to start putting our code separately. So I want to have what, a single file that helps us in what, in connecting to our database, or that handles database connection. Then I'll have another file that helps us to do what, to interact with what, our database, and also if need be, another file too, a pedantic file that will help us to do what, to carry out data validation, right? Data validation if need be, and basically that is all. And then our models file, okay, so if you're coming from another programming, if you're coming from Django Web Framework, then you must have heard of models. So basically they are like classes. So like I said, the way ORM works is that it basically maps your class to what, to a table in a database. So those classes are what we call as models. So they basically represent your table. So I will have a separate file that we can use for to be creating those classes that will represent our table in our database. So I don't want to bring in all those code and then put them inside one file. That wouldn't look nice, right? That wouldn't look nice at all. That wouldn't look nice at all. Right. So let's kickstart with all these things, and let's see how it goes. Already, we've used about 3 hours trying to put things in order. Sorry about that. All right, so quickly, I will create a new file. All right, I will create a new file, and we will create in our database dot py database.py. So database.py, all right, is a file that we will use to do what, to actually manage our database connection, right? That's what we will use to manage our database connection. And before we start to put in some codes here, we need our SQL alchemy, because we intend to use that as a bridge between your high level programming language and your query and your database, right? So let's go ahead and get that installed. To actually install it, since it's a third-party module or library, we make use of pip and then install, followed by the library name. And the library name is just SQL Alchemy. It's just that simple. SQL Alchemy. And that will get SQL Alchemy installed in our current virtual environment. Please, this installation is not being done directly to my hard disk. This installation is being done directly to our virtual environment. So it seems that we already have that installed. So I think during your fast API installation, that must have been installed as well. But if you're not having requirement already satisfied, then that will carry out that installation for you, right? That will carry out that installation for you. All right. So we can go back and reload our server. So having that installed, we need some functions in SQL Alchemy. Please, SQL Alchemy is a separate library, right? So if you're having difficulty with some function that we're going to use for that library, we can as well, in our spare time, look up the library documentation, right? That library has its own documentation. But for this class, I'm going to explain the necessary implication that we want from that library. But then if you still need a broader knowledge pertaining to that library, then you can pick up that library documentation and go through it, right? That documentation is not bind to a fast API. It's a separate library on its own, an independent library. All right. So first of all, we need to create an engine. So then to create an engine is basically need to a way of establishing a connection between your high level language and your database, right? And your and your and your database. Then to actually create that connection, right? We need the create engine function. Now the create engine function takes in your database URL. And when I mean your database URL, it's basically a string of characters that basically specify your database, your database engine, your connection details, and also your database name. And this URL varies depending on your database. So for this particular class, you will see how we will create the URL for our SQLite, because that's what we'll be using. Then when we get to deployment, then you see that we will have a different URL based on what on the database that we'll be using. So someone that's using Postgres will have a different, the URL will be different. Same thing happens with MySQL, but they're almost alike because that URL must actually carry your engine. So the engine for MySQL is different for Postgres. That they are okay. So what I mean by engine, I simply mean the underlying software in which these database are being built upon. So it is software that does what that helps you create and delete and interact with the database. So as such, that engine would vary depending on the database itself, right? So so like I said, we need to create that engine. So we need that function that will help us create that connection. And that can be imported from what from SQL Alchemy directly. So simply say from SQL Alchemy, so it should be from, not from SQL Alchemy, we want to go ahead and import create engine, the create engine function. All right. So now this function takes in your URL, yes, your database URL, and do what? Create and then create a connection between what your high level programming language and your database itself. So we can simply do that by just saying by just saying create engine, and then this man takes in what the URL of your database. So in this case, I would simply specify the URL. So what I want to do is I will just call this db underscore URL. And this db URL will be a variable up here. So this will be the URL that will carry our SQLite. So SQLite is basically it's a file database. So it lives in your system. It's mostly used for development sake. But then when you're migrating to production, you need to do was switch that database, because MySQL is not consistent. It doesn't hold information for long in production. So over time, the information in that file will get lost. So that's why it's not actually recommended for production. Okay, so I will specify my SQL, sorry, my database URL here. So for SQLite, we need to start with SQLite, because that is the engine that will process that file database. Now, like I said, this URL may differ, not actually varies depending on the database itself. That URL will actually vary. So for SQLite, we simply just say SQLite and then colon and then triple slash. All right, now the slash there, all right, actually lets Python know that man is a file database, right? Is a file database. And then what follows there is the location of that file, right? The location of your file. So I will call this codecamp, codecamp.db. That's the extension of database of SQL database .db. So it simply means that this file, right, the codecamp.db actually lives in our directory, our current directory here, right? But if it's not there, if it's not there, that this will be created automatically once you want to establish that connection. Once the table needs to be created, if the database is not there, it will create that database automatically for you. That is for SQLite, please. But when you're using Postgres, it doesn't do that, right? So you have to actually create your database and get the appropriate credentials, right? But then for SQLite, that will be created automatically for you, right? That will be created automatically for you. All right. So having that in mind, or having that in place, sorry. So I can pass in the URL to do what to create that connection. But then there's something about uh, SQLite, all right? So it does not support multi-threading, and we need to sorry, it only supports single threading. And we need to do what? We need to specify a configuration. This configuration is only meant for when you're using SQLite. Once you move to Postgres or MySQL, you don't need this additional configuration. All right. So since this is my SQLite, we simply just add another additional setting called connect arguments. All right. And then this takes in a dictionary. And then within this dictionary, we want to pass the key check same thread, and then we want to turn this off. So this takes in a boolean value, and then put this to false. So that way we are now forced to do what to actually support multi-threading and not a single thread at the same time, because multiple requests can come in at the same time, and we don't want the situation where that will cause what a request conflict. Now, this configuration is multi-threading configuration is actually default in all these other databases like MySQL and the rest of them. So you don't have to actually specify that configuration. So that is only necessary because we are using what SQLite, right? That is only necessary because we are using that. All right. So now after that has been done, I can actually assign this to a variable. So I can actually call this engine if I want to. Right. So that can be because we're gonna make use of this connection sometime in our project as we move further. You get to see that. So we don't have to repeat this whole code all over again. You can simply just do what just reference this code with a variable called engine. So after that connection has been made, let me just put a comment here. This establishes connection with database, right? And then the next thing you want to do again is we want to create a session. You want to create a session, right? Now consider session as a temporary workspace, right? A temporary workspace where you can perform a lot of tasks directly to your database. Let's assume that I want to add a record to my database. Then I need a session like more like a workspace or an empty container where I can do what put this action, and then do what happen, execute them, right? So that section, right, help you do what to interact directly to the database. So this man here does what creates a connection to your database, and then session helps you what to interact with that connection. You understand? To create engine is basically what creating a connection to your DB, but then in order to interact with this with the database, we need to do what we need to create session. So session helps you do what to carry out that interaction, right? So to do that, we simply need to bring in the necessary modules that help us create a session. So to create a session, we need to bring in session maker from SQL from from SQL alchemy.orm. So we simply come back here and then we bring this man in. So say from SQL, it should be from SQL alchemy dot orm. Then import. It should be import session maker. So session maker helps you do what to create that session, right? It helps you create session, right? The function that helps you to interact with your database. So we for each time we need to do what to interact with the database. We need to what create a session and then carry out the interaction and then do what close that session, right? So you don't want to use one session for multiple requests. So each request you need to do what create a session for that request, do whatever you want to do, and then close that session. All right. and then close that session. That's basically the concept behind that, or the idea rather behind that. So to create the session, I would probably just name, I would simply say session maker, and then in brackets, this man takes in bind as a required parameter, because if I want to interact with the database, which database am I interacting with? So that's where the bind comes in. The bind help the session maker to know which database to do what to interact with, which in this case is this one that we don't want, that we've established the connection. So I'll come back here and assign bind to what to engine, and that's that, right? And that's actually that. But then there are other few configurations that we need to actually do to avoid problems in the future. Now, those configurations are important. So we have two important configurations. We have the auto commit and auto flush. Now, what do these things do? These things actually, for auto commit, right? It means that that the session will automatically save changes to what to your database, and you don't want that, right? You don't want the session to automatically put those changes there, right? Because there are some other probably you may have a situation where you want to create a table, right? Sorry, a record for a table, but then you want to kind of add other checks before doing what, finally saving that record. But then with you not putting that attribute, the moment you create an instance for that table, it automatically saves that record, and you don't want that. and, and you don't want that. Same thing with auto flush. Auto flush or automatically send these changes to your database. So you want to turn those two things off, and then want to manually do it ourselves, right? Want to manually do those things ourselves. So we can do that by specifying that after binding this, I want auto flush to be what to be false, and we also want auto commit to be false as well. So you also want auto commit to be equals to false as well. Saying that wrong. This should be false. So we don't want that situation. We don't want that situation. We don't want the situation where auto commit is what is true. Sorry. So with that, we have created a session, and like I said, we also need this session for each time we want to do what to interact with our database. So for each time we want to interact, we need to do what to actually invoke this class, right? And then go ahead and do what and interact. So we don't want to be repeating all this code. So what we can do is we can assign this to to let's say a variable, and I'll call this variable session, probably session local, to separate it from the one that we just imported. Session local is equals to that. And the last and final test pertaining to the database is that we want to bring in the declarative base class, right? Because that's the class that we do what that we use to create each of our table. Remember, ORM basically what maps your class to what to a table in your database. So in order for SQL Alchemy to know that this particular table, or sorry, this particular class should be mapped to a table in your database, then that class have to actually inherit from where, from a declarative base, right? From a declarative base. So that function, right? You can also import it from SQL Alchemy. So all your model or all your classes that you intend for it to do or to represent a table in your database must inherit from that class, right? From that class. So we have to bring in that class, and that will be that for database configuration. So we bring it in. So this actually exists in extent.declarative. So you say from SQL, right? So basically, you don't have to cram where these things are located. As far as you know the function that you need, you can always actually look it up in Google where this function is what is being found, and then you can have the full path in order to import that function. So assuming I know that, of course, I need what a session maker to create session, and then I don't know where it's actually located, I can just go on Google and search for how to import session session maker, and of course you have what you have the directory where it actually located. Same thing happens with the declarative base. Right, so bring in that in. So we say from SQL alchemy.ext. So I'll say it again. SQL Alchemy is an independent library. It's not. It has no affiliation with Fast API. All right. So you can actually pick it up and do what and look at the definition and have a broad understanding of how this library actually works. All right. So it has no connection with Fast API. We are only utilizing it for the purpose of communicating with our database. So let's continue declarative, and then we import the declarative base. So basically, all your classes that you intend for it to represent a table must inherit from that man. So I will simply just assign this man to a variable called base, and I will say let base be equals to that function. So I'll basically just go ahead and invoke that function. Simply go ahead and invoke that function. All right, so and that is that. And those are the three major things you want to do what to configure in your database. So where this actually does what establish a connection with your database. The session does what creates helps you do what or create room to interact with your database, your DB, right? And this man is needed, and this man here is needed because our classes to represent tables must inherit from it. Question before we proceed. Any question? That's basically what you want to do in your database connectivity or configuration. Is there any question before we proceed? All right.
Please, I need to understand what that declarative base does. I want to understand what declarative base does better. Go over it again, please.
Okay. So, all right. So, before now, right? I said that we'll be using the concept of ORM, right? The concept of ORM to help us, right? To help us interact with our database in a high-level programming language without necessarily writing SQL queries. So that's the whole concept of ORM. And basically, what it does is that it maps classes to a table in database where each attribute of the class represents a column in the table. Right. So now, but then this class have to inherit from declarative base. Now the reason for that is that you can have as many classes within your function. All right. SQL Alchemy has no ability to tell if this particular class you intend to use it as what for ORM, right? So as such, in order for SQL Alchemy to know which class should represent each table, that class must inherit from the declarative base. So that's basically what that declarative base is. So it's there and it is compulsory that your class that you intend to represent as a table should inherit from that class then. So that class then comes with all the attributes and methods that you will use to do what to create your own table, right? To create your own table in such a way that what Alchemy will be able to do what to map it appropriately. Do you understand?
Yes, sir. I understood. Like it can be compared to like base model that inherits from what they call what pedantic. Something like that.
Exactly. So now that inheritance brings in all the attributes and all the built-in methods that will help you do what create your own table without doing what going to write from scratch. So imagine you writing from scratch a class that should look like a table in such a way that ultimately what we do what we actually understand. That's why it's quite stressful. So that's the whole purpose of inheriting these things, so it can help you do what create your own table as fast as possible, similar to base model in Pandantic. That's fantastic. Any other question before we proceed? Any other question? Any other question? All right. Silence means no other question. All right. So we can proceed, right? We can actually proceed. So that is basically that for database configuration. Now we have that in place. We can simply go ahead and do what and start creating our, our models. That's basically our table, right? So as usual, I will create a separate file for that as well. I'll create a separate file for that as well. So I will call this file models.py. So it means that all the tables that we will ever need in our project will live in this file here, right? It will live in this file here. So for a start, I'll just create very simple table, very simple table, very simple table. So I will probably, okay, I will create a table of user, all right? I'll create a table of user. So before that, I'll need to remember our table or our class need to inherit from where? From base. So you have to bring in that man base, right? You have to bring in that man. So I will simply say from current directory, which in this case, database import base. We need base, right? Because we want all our classes to do what to inherit base. So we can do what we can use it to create our model. So I'll create a simple one. Remember, this is a class. Remember, ORM maps your class to what to an actual table. So when you create a class, it simply means that that class is what is representing a table. So that means after your class name should you should provide what your class name, which in this case, they when creating classes in Python, after the keyword class, follow what your class name. So in this case, I may call this user, and and your class name needs to start with a capital letter, right? The class name needs to start with a capital letter, and this class will inherit from where? From base. This class will inherit from base, and then the first thing you want to do for alchemy, because if this was actually Django, then after this you can simply just start putting out what your attributes. But for alchemy, it is required that you provide a special method called table name. Table name. So underscore table name underscore should be equals to what the name of this table. So how do you want to call this table in your database? So in this case, I want to call this table users, right? I want to call this table user. Then below this, I can do what? I can start specifying each column of the table. Remember, each attribute signify each column. So if I intended to have a column of let's say name, or let's say first name, last name, right, and probably email, then I can simply just say first name, first underscore name, right, and we'll come back for that, and then I can also have last name, and I can also have email if I want to, right? And then one important thing that you should always put to your table is a column called ID, right? Put a column called ID. Is more like a numbering of each record. So it will be useful if you intend to do what? If you intend to fetch a specific record, right? If you intend to fetch a specific record, then that would be useful, right? That would be useful. So that it's always recommended that you have that there. But then if you intend not to have, or if you intend to use some other thing as a mean of unique identifier for each record, then you can actually have that as well. All right. But it's mostly recommended that to use an ID, which is basically what an integers of numbers, right, for to uniquely identify a record within your table. All right. So now we can do what we can go ahead to specify that each of these are what are columns, and each of these should have a specific type and some other necessary configuration for each of these attributes. So, but then before we do that, we need to bring in this method of configuring these things. Remember this, like I said, this is what alchemy. So it has its own method of configuring things. All right. So now to actually specify that a specific attribute is a column and should have a specific configuration, then we can bring in some necessary functions, right? Such as the models and some types. Right. There's some types that are native to SQL alchemy. So yeah, so we need to use we need to use those types, right? We need to use those types because we are because we are dealing with SQL alchemy. So let SQL alchemy what handle the interaction. So we need our column from, so we need to bring in, sorry, I keep having typo error in today's class, sorry about that. So we need to bring in some certain things. So from SQL alchemy, I need to bring in some implementation of things. So I need to bring in column, because column is what we use to specify that this is a column, and as such, it should have a specific basic types or attributes if you want. So after that, I also need to bring in integer. So integer is a type it's a type in SQL Alchemy, and I also need to bring in string for now. That should do. Those two things they should do. Need to bring in string, right? And then after that, then I can simply just say let this particular attribute be equal to what a column. Now a column here is a function, and then this function can take a lot of attributes, similar to the pedantic fields, where we can do what where we can specify some specific variations for that specific column. So you could see that that these are all the attributes that column can do what can actually take. So you can take in primary key, you can take in auto increment and rest of those things, and the rest of those things. So I can also come here and then I could say that I want this man to be a type, because the first thing that your column takes is what is the type. Well, so what is this attribute which is seen as as a column? What type of data should be accepted in this specific in this specific column? So in this case, I want my ID to be integer, and I also want that SQL Alchemy should see as as the primary key. So the primary key takes in a Boolean value. So in this case, I can just specify that this should be true. True means that, of course, this should be what my primary key. That's my unique means of identifying a specific record, right? And then same thing, I could also apply the same thing to the rest of the fields. I could also have that in your spare time, you can also look up other parameters that the column can actually take. You have the auto increments, you have the defaults, you have a lot of them there, right? So the whole purpose of this class is to help you understand the flow of these informations. And then in your spare time or in your visual time or in your free time, whichever one you want to use, you can go up there and look at this library appropriately. Probably see some other parameters that may fit your needs, right? That may fit your needs. All right. So I'll, and then it is also necessary that if you have that it's also should I say, recommended that you should only specify one attribute as your primary key. So if you already have a primary key, you don't have to specify another primary key in the same table, right? Except you want to, but then it's not recommended. So one is enough. One is enough for each table. So in this case, I want this particular column to accept only what string. In this case, accept string. And I think the same thing works for the rest of them. Same thing works for the rest of them. And that is basically what a table of users. It's just that simple. It's just that simple. And then with this, SQL Alchemy will behind the scene do what write the appropriate SQL code queries to do what to create that table and guide out whatever interaction you want. So if at all you wanted to create other tables, then of course you can still go ahead and do what I'm creating if you see fit, if you save it. And I probably could just call this one maybe books, or maybe I could just call it item, could be anything. But let's call it books for now. So in this case, I'm going to call this one books. And ID it could be the same. Probably this could be my book name, and you can have every other attribute if you want to. If you want to, you can have every other attribute if you want to. So that's just basically how you do or how you create your tables in high programming language. In high programming language. In this case, Python programming language, and Alchemy do what will do the rest for you. It's just that simple. So all your tables you want them to do what to live in what in your models of pi. All your tables you want them to live in models of pi. Right. So in our next class, we're going to talk about relationships in table. Right. We will not and that will not be in this class. In our next class, we'll talk about relationships in table. So but for now, this is how you can do what create your table. Is there anyone that don't understand what is going on here? These are basically what Python classes, right? But then when behind the code, Alchemy do what will write what the appropriate SQL queries that will create this table with all these attributes, right? With all these attributes. That is the whole access of what of ORM mapping, where it maps what your class to a table in a database, where each attribute, right, now represent what a column in that table. Do you understand? Do we understand?
Yes, I understand, but one question. The underscore table
All right.
name underscore is it a default name, or can it be anything?
It can be
Called
anything,
ND.
whatever you want to name your table. Yes. No, that name there is a special name for SQL Alchemy, right? So you must carry that name, but then the value of this name is basically whatever you want to do what name that table, right? Which of most times that name will almost tally what with your class name. But then the underscore table name underscore is a unique name. It is a special name, so that name must be there. It must be that way, right? But then the value of this name can actually change depending on what you want. Is that okay?
Okay.
All right. Okay. So having that in mind, let's also proceed. So basically, I could also have a, a route that should create the users. But then remember, before now, we will do what we would actually create our parenting model here, right? And then give it the schema, right? That should of how our expected data should look like and the variation. But we can't keep doing that again because over time you may likely be getting a lot of information. So imagine having like 100 schema in your main.py. Before you can even scroll to where your route starts, it doesn't even really make the code looks nice. So what you can also do again is what you can actually put that schema in another file, right? And in this case, you can call this file schemas, schemas.py, right? And this file will hold all your parenting model. Basically, your model that will validate whatever is coming in and whatever is what is going out. Okay, so you see the bit of it. So your schema will do what will validate what is coming in and what is doing what going out. So I'll simply do what create a schemas.py rather. So okay, so this should be called schemas dot is this no it shouldn't create there. Shouldn't create there. Sorry. This what you want to create this in your actual file. So schemas.py. So this is what your pandantic model file, right? Your pandantic model file. All your pandantic classes, you want them to live in this file, right? You want all of them to live in this file, right? You want them to stay here. So you don't have to go to your main file and do what and be writing a lot of pedantic models for validation of input and output, right? So you can just put all those things in this one file and the rest of them will do the work for you. So simply, I'll just since I have a model that creates a table that creates users, so that I basically also want a schema that should validate what user information is coming in. So I'll go copy this man and do what and edit it, right? And edit it. So, which I don't think it should look confusing for us because we've already been doing these things for a long time. So I'll simply just say from Pydantic in this case. I keep typing from into this class. Sorry, it should be from Pydantic. From Pydantic, you want to import our base model because this model helps us to do what? To create a schema that helps us validate these things without us necessarily writing much code. So basically, your class should just inherit from this man, and then you can go ahead to do what.
Yeah.
Right. Sorry about that, guys. I think my network kicks me out. Network kicks me out, and Ada, you're not a host because I made you co-host. Please, can you do change of ministry? Okay.
Okay. How do I do that?
You just right click on my name. I think probably carry your mouse on it. When you just see something, an option on my name, and then you just have you seen that?
Mm, It's not my phone and what I have. Okay, I've seen it. I've seen it.
Sorry?
Oh, I've
Okay.
seen it.
All right. So I will still make you co-host again. All right. Okay. So you're automatically co-host. So just in case. Right. So right. So back to our parenting model. So I was saying that we have a model that saves users, right? Or that creates user to our database, and then we basically just want to do what? Write a parenting model that validates what is actually coming in, right? So it will validate that for us without us necessarily carrying out much check. So since this is Pydantic, and this also takes in mostly native data type, mostly it takes in most of the Python data types, and then it uses type hinting, all right? So Pydantic actually uses type hinting, so in this case, I want this to be colon, not equals to. So this should be colon, and then this should be integer. So Pydantic will confirm that should be integer, and but this should not be string. Same thing should happen to the rest of them. So that will just validate that for us. All right, and that is that. So that easy. So we have our model there that will validate what is coming in, and we likely validate what is going out if you want to. That will validate what is coming in, and will likely also validate what is going out. Right, so having that in place, we are almost good to go. Almost good to go. So we have our database connection. We have our model, that is our tables, right? That makes of that makes of ORM that maps classes to what to table and attributes to what to columns. And we also have our schemas that should handle whatever is coming in, input validation and output validation if you want as well. So we are beginning to have a lot of files here, right? So files are beginning to get much, and that is basically that. So one more thing again, right? One more thing is that well, we could also be writing our code like here, right? In our main.py, there is no problem doing that. It's absolutely no problem doing that. But then in a situation where probably in a situation where we want to we repeat a specific code operation over and over and over again, probably in different routes, then it means that what that we have to do was we route that same code in those separate routes. Okay. So it is always convenient that what that you have another separate file, and then that file should contain all your CRUD operations in this line, whichever CRUD operation that you intend to do, right? That file should do what should handle it, so that you don't have to write those code twice or multiple times. You can basically what import the code and just keep using them whenever you see fit, right? Whenever you see fit or need for them. So I'll create another file and I'll call this file crude.py. So this file will handle every interaction that we intend to do what to interact with our database. So I want our main.py to be as neat as possible. But I want our main.py to be what as neat as possible. So that we can say that we have what a file for database, a file for our tables, a file for our pedantic validation, and also a file for what interacting with the database. So everything in that is almost in order, right? Almost in order. So basically, at the moment, I want to write a CRUD operation that actually create or add information to our database. Now, these steps are similar. These steps are what are similar depending on whatever table, as far as you're adding information to that table, right? As far as you're altering the table, right? The following step is what is actually required. Is actually required. So in alchemy, so I'll basically just put more like a doc string here. So the thing to note is that in alchemy, right? In SQL alchemy, right? In SQL alchemy, to create data, you need to follow some certain steps. Now, these steps is only when you want to intend the word to create, like to add information to database or to a table that you've created. So basically, you want to do what you want to create the instance of. You want to create. First of all, you want to create a SQL, which you don't worry, you see this in coding. But let's just put out these steps here. Want to create an SQL alchemy model instance with your data. So let's assume that I intend to do what? I intend to add a record to let's say to the table core users. So it means that I basically need to do what? I basically need to create an instance of this class with the record specifying each value for each attribute of this class. You'll see what that means. What in that English that I just spoke, I will show us in programming. So basically, what I meant is that if I want to add a data to my table, I need to do was create an instance of that class, probably the user class. Now, if I invoke this, that becomes what the instance of that class And then within this instance, you need to do what to specify the attribute. We have what the ID along with what with the values for each of those attributes. In this case, ID of what one, our first name of what data, last name, and so on and so forth for each of those data. That's basically what I mean there. Then after you have done that, you simply do what you simply add that instance to the database. To the database. Right, and then after that, because we turn off the situation where this man should automatically be sending changes to our database. So you need to do what we need to manually do what put that changes there. So we go back again and create, and then we do what after you add, you do what you commit. So this way you want to do what to carry out your data commit right to your database. After that, you do what you refresh. And the reason why you need to refresh that table, right, is that so that table do what, so that when a new request comes in, right, it do what, it will find the recent data that was added to that table. So that's the whole essence of what of refreshing. So that what the table will be up to date. So that if a new request should come in after adding that record, that request should be able to see that new record now, right? So that's the whole purpose of doing what of refreshing. The whole purpose of refreshing. All right, so let's put out a function. So this is more like if the code will mostly be what a function of queries or of query, right? That we will likely be using in other routes, so that we don't have to be writing this query or this particular set of instructions over and over again for each route. So what do we package all of them as a function and put in what in the code file. So we simply reference them when we see it for what to use them, right? So that's the whole purpose of putting these things like this. So I'll create a function, and this function I'll basically just call this function create a user function. So create a user function. Create a user function. And this function, right? I want to do what? Of course, remember that during our database configuration, right? We said that in order to do what? To interact with your with your this in DB, we need to do what? We need to do what? To create a session. So for each interaction, do what? You create a session, and then you do what? You interact. After interacting, you do what? You close that session. You don't want to keep that session open, right? Now the reason for that is that if you leave it open, it does what? It will consume space, right? It eats up the memory of your application, and finally your application will start lagging. And apart from that, to avoid request conflict, because if a session is actually open and then a new request comes in, and then probably it may result in that request altering what the previous request that was done to that same route. So basically, you want to be creating each session for each request, and then closing that session the moment that request has been processed and sent, and a response has been sent back to the client. So we'll see how we can do that, right? We'll see how we can do that. So going back to our create.py. So having in mind that in order to interact, we need our session. So I will read what we need our session. So I'll provide a parameter here called session, and then we also need the user that we intend to create, because if I'm creating a user, where is the details of that user that I intend to create? So now this function takes in what? Two things. Basically, all our create function will always take in what? Session, because we must create session in order to do what? To interact with the database. So basically, all our function will always carry section, and probably any other optional parameter that will be required for the create operation. right? Which in this case, we need the details of what of that user in order to do what to carry out this operation. Okay, so having that in mind now, I can now simply say that we want to do what that we want to create, what's going on, that we want to create our user. So now what happens is this: I could basically just call this new user, and new user should be equals to, we need our schemas, all right? So we need remember we need to do what we need to create the instance of that model. So we need to create and we need to instantiate what our user model. So we need to bring that man in. So in order to do that, we can simply just import them down here. So I will simply say from I will simply say from current directory, which is in this case our current directory is the models. We need to import. We need to import. We need to import our models. Probably we could just say from current directory rather. So we need to let's go ahead and import the entire model file. Now the reason for that is that we may likely want to use all the models there. So we don't want to be specifying each model one after the other. So let's just go ahead and bring what the entire model down here. So from the current directory, I want to bring in my models. Right, so I want to bring in my models there. And for now, that's what I want. And we also want our session. Remember, we need session to interact. We need session to interact. So we'll bring in session from SQL ORM, from SQL alchemy dot ORM import session. All right, so we need that to do what to work with. We need that to actually work with. And to shorten this up, I could just say this should be my GB, and this should be a type hint of what of the session object of the session object. All right. So now we have that now. Now we have that. Now I can do what create an instance of what of that alchemy class or of the alchemy model. So that would be what models dot the class itself, which in this case we want what the user class, and then within this user class is our attribute alongside with what with the data that we intend to do what to have. So remember our attributes here are we have the ID, we have the first name, we have the email, and we have the last name. So we can actually go there and then we can specify that. So first name, last name, email. The first name, last name, email. So going back to our CRUD. So we have our ID. ID should be equals to user dot email because dot ID rather. And that is ID will come from where? From the user itself, from the Pydantic user itself, right? From the Pydantic user itself. Or then we could also have that we could also have the first name, first underscore name should be equals to user dot, we also have first name there, first underscore name. This attribute, this ID and username are coming from where? From the schemas themselves. That's because whatever is being passed, whatever is being sent in, right, is coming in as a schema, right, as a Pydantic object because we have to pass that validation. So what again we need again is we need our last name, and this should be user dot last name. Same thing will happen with the email. Email should be equals to user.email. All right. And that will do what? And that will create what the instance of what of the alchemy what model. So after that has been done, what you basically need to do is to use your session to do what to interact with the database. So you could basically just say gb and then dot add. All right. So this is since this is a session, that will do what that will help us interact with this man. So the DB here is what is an object that is of a type of what of a session object. So that shouldn't cause of a problem. But after that, you can just simply just add new user. So you want to add that model to what to our database. So basically, what is happening here is that for each time we do what we create an instance of the Pydantic model, of the alchemy model. It basically represents what it basically represents what a single record of that table or of that model. So that what I'm saying is that go ahead and do what and create a new record. So here is basically doing was creating a new record. Here is basically creating a new record. So this should be hash, not here is basically creating a new record. A new record. And once that has been created, then you can now confidently do what? Go ahead and commit this into our database. Right? And then that one that has been done, you have to go ahead and do what? And refresh. And refresh. And what do we intend to refresh? We want to refresh the new record that what has been just been added. And that has been. And then after that, you want to finally return the new record that has been, the new user rather, that has been created. So now whatever we need to create a user, we have to do what? Basically just import that function and do what? And use it. And then every other function that we intend to use, we leave in this group.py. We have questions. You have questions. Question.
Question.
Yes. Okay.
All right, go ahead and answer.
The DB which you called was not imported. So how is
the
it?
DB? Right. So the DB is a variable name that belongs to that is type referencing, right, a session object up here, or similar to when we are getting data in our route function for validation. So what happens once we've created our identity class and then we've provided the necessary validation, what do? We pass it as a type to an attribute, or sorry, to a function parameter of the route. So same application is happening here. So we have a session object here. So we basically just pass that session object as well as a type to a variable called DB. So now once I say DB, I'm basically referring to what? To session. Right there.
Okay. Then the user, you did not import.
Right. The user model, this user here.
Yes.
Yeah,
No.
the user would be sent from the route function. Okay, so I'm basically saying that all right, that you see this variable that we have here, the DB and this user, they are basically like what? Path parameters. Sorry, they're basically function parameters or function arguments that will be passed in the route function where we intend to interact with it, right? Because this is should I say more like us doing what? Packaging our code as a model, right? Where we don't have to be repeating this code when we want to use it, right? So it's similar to us saying that, okay, assuming we have have an operation, right? Say 10 plus 10, right? And then we want to do what? And then at a situation where the final answer should not be should should, excuse me, should not be initial. Initial should be equals to 10 plus 10, and then final can now be equals to initial divided by 2 in the final, right? And then this operation will likely be repeating it, right, frequently, but then with a different value. So it could be that this time around that we want to repeat what we want, let's say with 20 and 10, and so on and so forth, right? But then we don't want to be repeating the whole code like this. Each time we want to what can add that operation. So what can we do? We can wrap this in a function. So we can call this a function of anything, a function of anything, right? And then this function should do what? Should unpack. We create room for what? For A and B, where A and B can be representing these values here, right? Where A and B can represent those values there. So it means that whenever you want to do what, to kind of add that operation, basically what do? We invoke this function and do what? And provide whatever values we do what we want, which in this case anything, and then we provide those values, probably 10 and what and 10. And then we don't actually need to do what to repeat all this code again. But then that what happens that code they gets repeated for each time we want to do what use it and for what and for different values. So same thing happens here. Usually or normally or by default, we could have done what? We could have copied this code as it is and put it in our route function, right? But then I'm not saying that we may likely use or we may likely have a crude operation that we may repeat for multiple route function. So in that case, it won't be nice, assuming that this function, like that this code is meant to be repeated in like 4 route function. It wouldn't be nice for us to do what? To copy this code about 5 lines or 5 or 6 lines of code there and do what? And keep replicating it in those route function. All right. So what do? We now package this code as a what? As a function, right? As a function. And since we now say that in order to interact with what? In order to interact with in order to interact with the database, that 2 things is required. Or sorry, 1 thing is required. One of it is what? Is a session. The other is probably anything you want to either add or extract from the database, right? So, which in this case, which in this case we intend to do was to create a user. So basically, what we need a session, right, to interact with with the database, and the user that we intend to do what to add to the database. Now, where will we get these things? We will get these things in the route function, right? So that means in the route function, when I intend to add a user, I basically just do what? Invoke what? Create user, and then we need to provide what? 2 required arguments. The sessions at that moment for that particular request, right? Remember I said that we need to do what? Create a session for each request. So at that request, I'll do what? I'll provide the session for that request, right? So that session will come in here. Probably I'll call session A, right? Take for instance. So now I'm not saying that the first parameter should be seen as what? As DB, because basically the session is what is connecting to what? To your DB. So it's more like me saying, okay, this is the database I want to do what? To interact with. And then after that, I want to do what? I also want to do what? To provide what? The user. So that means I have in my route function, I have gotten the user from where? From the API request, right? And then do a pass that user down to what? To create user function. So my user will come in here. So what happens that those values that we provide will now be sent to what? To this function, and this whole operation will happen. And then I can do what? Assign this man to a variable called user, right? A variable called user, and at the end of it all, Once this function has finished invoking, what happens? It returns what the user that has been what created. So it means that before this has been returned, that record has been created. You understand? So the session, the DB here is basically saying is basically just letting us know that it will be what a session object. Remember, this is type hinting, and this is what our normal Python script. So it does not actually force type hinting on Python. Type hinting does not actually force validation. That only happens when you are dealing with parenting, right? Once you do type hinting in parenting, it forces it. It forces that validation. So here now we are basically just saying that if we intend to do what to invoke create user function, man, you can see that hint there. That the first variable is what should be seen as what should be a session object, which will pass in the main in the route system function, and then what the user, which in this case should by default should be a pedantic object, right? A pedantic of you, sorry, a should be a user pedantic listing object. So it means that if you're passing the user, you're expected that you should pass what you should pass a pedantic user. This man here, right? So it's more like creating room for what for values to come in. You can take those things off if you don't want to put those hints, right? You can go back to your code and remove this section here. And basically, what those means that once you want to create a user, you pass the session for the database alongside what with the user you want to do what add. And what happens? This man here will happen, and then this man here what will return. Does that make sense? Are you following?
Yes, yes, yes.
All right. So Mr. Timitope, are you still with us? Does that make sense?
Yes.
All right. So that is basically that, right? So that's basically the file that we need in place, right? That basically the file that we need in place. So now we have all these files lined up, and then we know what each of these files will be used for, right? We know that the CRUD will be used for anything pertaining to interacting in what with your database. So in a situation where we also probably wanted a function, right, that should do what a function that should extract all users. So I'll also come to what to CRUD and do what and say get all users, right? And then because this function is meant to interact with my database, this function must take what a session. So next I'll put what my DB there. And since I am interacting, I am getting all user. I don't think I'm sorry. There's no need of me being more passing any information to the database. What I can probably pass is what is the user database. So within this man, I don't I don't need to do what I don't need to pass any other variable. And then within this function, I can do what I can now come here and do what and put all the code to do what to get all users, right? And then in my route function, anytime I want to get all users, what do I do? I create a session there, add that session to this function, and do what at the end of the day what gets the list of all the users in our table. So that's basically what the CRUD is meant for. The CRUD is meant to do what to hold all your interaction with your database, and every CRUD function must always carry the session, or must always create room for it to provide a session for that particular request. Because each time you want to make a request to your database, you must do what create a session for that particular request, and then create that session afterwards, sending out a response. Right. So that's basically what CRUD of Pi would do. And one database will do what will basically just do what connect to your database and do what and create session and create a session to that database. The bind here, right, helps to do what helps Alchemy to know which database am I creating the session to, right? Which database do you intend for me to interact to? That's what this bind here does, right? So it binds to that session to a specific database, right? And then this man here basically does what provide the all the tools that your classes will inherit in order to do what to create a table to kind of the ORM, right? To map a class to what to an actual database, to an actual SQL what table, right? And your models, of course, that's where all your classes do what it will live. Your class that would what that you intend for it to represent what a table, right? And then each of the attribute for that class will represent what a column in that table. And schemas, of course, for your what data input variation and data output variation. Question before, but that is where we are likely going to wrap up for today's class. We've exceeded our time. Though we started late, and I am sincerely sorry for that. Yeah, question.
Question. Yes, question.
Okay.
So please go back to the crude Python file. Yes.
All right.
So the first question, I think you mentioned something regarding maybe closing the DB because of I don't know, I can't really remember.
Yes.
So, but did we close it here, or is it closed automatically after writing this?
No, it's not closed automatically.
That...
In our main.py, right, we will write because that's where in our main in our actual file or in our actual route file, which in this case was our main tool.py file, right? This is where we'll be creating those sections for each request, and this is where we'll be ending those sessions, right? So what this man and what we basically did here was what to add to our database and what and update that database so that if a new request comes in, then if a new data was being added, the new request can actually see that new data, right? So, but to create and end a session, that will be done in our main.py file for every request.
Okay. So question number 2.
All right.
Question number 2.
All right.
Is there a way such that instead of telling the user to put ID, is there a way, maybe SQL Academy or
yes,
I don't know what we are using? Is it SQL Academy? Is there a way it can generate its automatic ID, yes. And how do we go about that?
There is a way. So like I said that what that SQL Alchemy, right, is an independent library. So that library has a lot of features. And then one of the features we had there was that we have a class called column, and this column can be used to specify some configuration for that specific column. And also make list that column can carry as many attributes as possible. One of that attribute also is called auto increment, right? So you can, in fact, the moment you specify primary key is equals to true, this Monday will automatically add that thing for you automatically. So, but I wanted us to just actually put that there. Then probably after like a first trial, we can come back and remove it, and then we'll still see that would be added automatically for us, right? So that can be, there is a parameter that can auto generate it. Is there. We're gonna actually do what use it because we wouldn't want to do what to be doing that by default, right? So after our first request, we remove that column. Like so, either do not have to do what to specify his or her ID. So we'll do that automatically from our end. So there are parameters that we can also specify, and these things happens automatically. Right. So this one will just at the basic. When we come again, then we can now dive into those other parameters, right? So the whole concept of this particular class was to understand the flow of these things, right? Where it starts from and where it ends at. Right? So, but then we'll come back and then we can add as many attributes as we want to meet our specification. So yes, there is a way we can do what auto generate it. I've answered the question.
Yes, you have. And the second one is just my concern for our class.
Okay.
Is it possible for us to get maybe information beforehand if class will be late?
You know that this
will be a little bit delayed.
Okay.
And the like. So yes, please. If class will not be holding, not that we send requests. Maybe it's you, because sometimes I do done for 1 hour. just waiting to be granted through because it has happened such that you do start class sometimes by 8 p.m. So you just have to wait because you never know when the class will start. Since you never got any info beforehand. So maybe there's a way we can get information if our class will be late, or perhaps we'll not be having class so that we will know what to do, please.
All right, so please, confirm that you can hear me, please. All right, so for that,
yes, I can hear you.
okay. Okay, so for no, this is there's some technical issue that will just come up and then it's beyond our own control, but then probably within us, right? We are trying to hopefully that we can rectify that and still hold a class at the same time. But at times, this thing just takes longer than I should, and and then information tend to come in quite late. But sincere apologies for all that. My sincere apologies for that, and we improve on that. Right, please. I'm sorry. I am apologizing on behalf of the entire program. We are sorry about that. That should not be happening by default. That should not be happening. But see, this is step one. And step one, the more solution that we create, of course, that solution does what tend to create more problems. So on and so forth. So please, I am sorry about that. I am sorry about that. That should not happen again. Any other question?
All right, you
Any
made
other question?
mention of an assessment. When should you be expecting the
Yes,
assessment?
yes. They will be, the moment I end this class, that assessment I'll drop it on our elements, and that should not take us more than 24 hours maximum. If you sit down 1 hour, you've solved all those problems. Very simple question, which I intend for all of us to finish quickly. Right. So I'll drop it and I think it should expire tomorrow 11:59 p.m. I think that should be 48. That should be complete in 4 hours. The simple task. Right. So that will come up. Right. So and very important, please. Let's try to be what to let's try to always maintain the current stage, right? So that we don't get left uh, left out in the first phase. It is we've come almost okay. So that means the we've passed the midway, right? So that means we've come more than halfway. So it will not be nice that you've come that far and end up not being in a perfect phase. So please, let's try to always be on the same stage. Please, I don't know how I will communicate to all of us because I'm trying to communicate that and it seems not working. So please always once in a while come to the group and let them know that they should be on the same stage. I am really available to grade. Just let me know that you've done a previous task. I'll go back and grade it. Because in my own ends as well, I always go back to an hospital for previous tasks. If there's anyone that have done any previous task, and if there is, I grade the person. But just in case I don't go back in time, right? You can also you can always come to do and let me know that what that you just did a previous task, and I'll do well to go back and do what and grade it. That is my job. So that as fast as I can, right? Or should I say as soon as I want to before we run it up. Any question? All right. So so the silence means no other question. Please, guys, do have a wonderful, wonderful good night rest. And please, like I said, go back to your elements and check 30 minutes from now. There should be a new task there. Try and do it within the next 24 hours. You should be done. And I'll see you guys in Tuesday next week. So bye for now. Have a wonderful weekend ahead as well. All right. Bye for now.
Thank you. Good night.